What's up guys, it's Talha here and today we are going to study about queues and this is another data structure just like stack, but there's a small difference which you guys will see in the upcoming slide, and that is lecture number 4 by the way. So a queue is an ordered collection of items, means that order doesn't matter in this data structure, where the addition of new items happen at one end called the rear end, means the back of the queue. So when you add items, you'll always add at the rear end, the back end of the queue, and the removal of existing items occur at the end. Uh, and the removal, and if you want to remove an item, you'll have to approach the other end, that is commonly called the front. So this right here is the front and this is the rear. From here you add the elements and from here you remove, oh sorry, uh, from here you add the elements from here, and from here you actually remove the elements from the rear end and the elements from the front. So actually hmm, okay, so queue data structure. So NQ operation is adding the elements in the on the rear end, and DQ operation is removing the elements from the front end. NQ is the operation for adding an element into a queue, and DQ is the operation for removing an element from a queue. So queue data structure. So this is an example of implementation of queue, and this is how you will implement queue. So first of all, when a queue is empty, so head and tail, or you can call them the rear and the front of the queue, is the same, means the pointers, the head and the tail, both of these pointers are pointing to the same same location of a list or an array, because you can implement a queue with the list or an array, it's up to you. So both the pointers are pointing to the same location, and when an element is inserted, means you perform an NQ operation. The tail, so you're adding elements on the tail of this, on the tail pointer of this list. So then the you add an element and the tail pointer move towards and the tail pointer is incremented, so it moves towards the first location, and it moves towards the second location, and on the first location you insert an element, and next you insert some more elements, and the tail pointer move towards the fourth location, and you have the head at the same location, that is 0 because you didn't delete any element. So if you want to now delete an element, what you do is you perform the DQ operation, and what that does, it increments the head pointer, and the head pointer moves one more, means one forward, so that the head pointer is now at the second location, and the zeroth, and this is actually kind of wrong, because the 19 is gone, so 19 should be here on this location, and 17 and 7 should be here, because the head pointer moved one forward, and that is how actually you delete elements from queue or stack. You just change the pointers. You don't actually delete that element from the list, and that element might be overwritten in the future. So this is the tail, where the tail pointer. So just to revise, you add elements at the tail, and you remove elements from the head, and this is all the game of the pointers. So basic features of queue, like stack. Queue is also an ordered list of elements, as I stated. of similar data types. So just like a stack is an ordered list of elements of similar data types. So just like stack, queue is also an ordered list of elements of similar data types. Queue is a FIFO structure, not FIFA. FIFO structure, first in, first out structure. So here, so this 27 is the first element you've inserted now. But as you insert elements, this 7 is the most recent, or you can say the first element you have inserted, this 7. And this 27 is the last element you had inserted, and this 7 is the first. So first in, first out means that, okay, where is it? Sorry. It's a first in, first out structure. So here you okay, so actually it confuses me as well a lot of times. So okay, so you insert elements. So this is the element you've inserted, and you inserted this, okay, no. So okay, so 7 is inserted. Okay, it's actually confusing me as well. First in, okay. So here, 27 was inserted in the first place, and the 7 is inserted in the last place. But Q is a structure first in, first out. So 27 is inserted, and when, as I said, when you will delete an element, it will be deleted at the head or at the rear end. So this was the first element inserted, and when you will delete an element, this element will be deleted right here. So first in, first out means first element inserted, and the first element was also deleted. But in case of a stack, where insertion and deletion happens at a single point, so if it was a stack, then it wouldn't be first in, first out structure, because then the first element that would have been inserted was 7 here, 7, and then there is the last in, first out structure. So 7 was to be 7 was to be deleted from the stack, but in this case 27 is deleted, so that is why. So and 27 was also the first in element, and it's also being deleted. So first in, first out. Once a new element is inserted into the queue, all the elements inserted before the new element in the queue must be removed to remove the new element. So this 27 was the first element which was entered, then 19, 17, 7. So now if you want to delete this 7, is this 7 element, means the element in the third location, you will have to delete all these three elements before you can delete this one. So that is why it's first in, first out structure. Peek function is often used to return the value of the first element without dequeuing it. So that is the same as the stack. Applications of queue. So serving requests on a single shared resource. So resource is shared, is a when a resource is a single shared, then you have to wait. So every request is in a form of a queue. So when one is done, and then the second one arrives, and it goes on just in the form of a queue, like a printer, CPU task, scheduling, etc. In real life, call center for phone systems will use queues to hold people calling them in an order until a service representative is free. So when a service representative is free, until then the people are being put to hold in a queue. So in a it's a first come first serve kind of structure. Handling of interrupts in real-time systems. So interrupts are small programs which need to be run by the CPU. So if there are 2 or 3 interrupts, then the CPU will actually the processor will actually arrange them in the form of a queue, and the first come first serve on the first come first serve basis, the tasks will be completed by the processor. So the interrupts are handled in the same order as they arrive. So first come first serve. So the queue abstract type queue creates a new queue that is empty. This is a class. Queue is a class, and now here you're creating an object. So creates a new queue that is empty. It needs no parameters and returns an empty queue. That's pretty self-explanatory. And queue item adds a new item to the rear of the queue. It needs the item and it needs this parameter item and returns nothing. DQ removes the front item from the queue. It needs no parameters and returns the item. So it's basically removing the item, it's basically deleting the item. So that is why it is returning the item as well, to show that which item did it delete. Means that now that item is no longer part of the queue. The queue is modified, of course, because you're dequeuing it. Is empty is a function test to see whether the queue is empty. It needs no parameters and returns a boolean value. So if it's empty, it returns true. If it's not, it returns false. Size returns the number of items in the queue. It needs no parameters and returns an integer. That's pretty self-explanatory as well. So now this is an example queue operation. So queue operation, queue contents return value is empty, true, yes, this is empty. Enqueued 4, then we enqueued dog, then we enqueued true. True means true is an element of this queue now. Size is 3, is empty, false, because this is not empty. NQ84, yeah, okay, so this is 8.4. Actually, I'm not wearing my glasses, so I thought this was 8 and 4. So 8.4 is a float, okay. 8.4, okay, so you want to dequeue. Now, the first element that was inserted will be okay, so you enqueued 4. So the last, what was the last element? That means what was the first element we enqueued? That was 4, and this 4 will be removed. So first in, first out structure. So dequeue 4, dequeue again, and then the dog was inserted after 4. So first in, first out. So dog will be removed as well. And now the size is 2. So that's pretty, that's a nice example. Then you have a program, and we haven't studied this, but I'll be covering this in future few videos. I'll be covering the rest of the slides in future videos, and till then, I hope you guys have learned. I hope I've taught you until here, so you guys now know what that is, what queue is, and I'll see you guys next time.